In this video, I'm going to discuss about the yet another palindrome problem which occurred in the Codechef Starters 60 challenge. The problem states that chef has an array of size n. In every operation, he can choose an index I, and from the left side of the I, including it, all the elements he can increment by 1. We have to find the minimum number of operations chef has to perform so that the array becomes palindromic. That is, if 141 is palindromic array, 7337 is a palindromic array. So if it is not possible to make it palindromic, we have to output -1. Okay, so the sample test cases were as follows: 4224, it is already palindromic, so output will be 2. 54321, output will be -1 because there is no possibility to make this palindromic. Okay, because 5 we have to either make it 1 or 1 we have to make it 5. So we have to increment it, so obviously we have to make 1 5, and if we make 1 5, then we have to obviously touch 5, because it is said that in the operation you have to touch all the elements in the left side of it. 1 2 3 4, yes, we can make it. We can make it in 3 operations. Okay, so let me first discuss how to the explanation of the code. Okay, so first of all we need to check the difference between the first and the last element. Okay, the last ARR of last minus ARR of first. If that is lesser than 0, then we have to return false. That is -1. Okay, -1. That is -1. And else we have to let's say answer is equals to ARR of last minus ARR of first. Okay, this is the answer. This will be the answer if we satisfy for all other elements. Okay, this will be the answer. So let's store this answer into a variable which, let's call it final. Okay, final is equals to answer, and we need a flag for this problem. Flag is equals to 0. Now we have to run a loop from I is equals to 0 to I less than n by 2, and obviously increment 1 every time. So we have to check if ARR of n minus 1 minus I minus ARR of I, that is this minus this, that is the palindromic positions, which should be equal. Okay, if that is greater than answer, then obviously we have to return it false, because if we increment this by some number and we have to increment this by a greater number, we can't do that, because you know the left thing. Okay, so if this is greater than answer, or if ARR of n minus 1 minus I minus ARR of I is lesser than 0. Okay, that is this condition. Okay, which condition? Yeah, this condition. Okay, advanced form of this condition. So if this happens, then we can return -1, that is false. Okay, and every time we do this, we have to make answer is equals to modify it. Okay, modify answer as ARR of n minus I minus 1 ARR of I. Okay, minus ARR of I, that is modify it every time. So let's say 4 minus 1 is 3. 4 minus 1 was 3, and after we do this operation, 3 minus 2 becomes 1. So we have to modify answer as 1. It was earlier 3, then modify it to 1. Okay, you get it. So if this array runs successfully, this loop runs successfully without breaking, that is returning the false, then we can say we can print the answer. We won't print the answer. Okay, answer has been modified, but final has never been modified. We have to print the final. Now you may ask that why I use the flag, because you may not return, you may not use a function for this. So in that case you need a flag, that is you have to print -1 and make the value of flag as 1, and after exiting this loop, if flag is equals to 1, then print -1, else print final. Okay, which was the answer. So this is basically the code. Let me explain it to you in a little bit more fashion way. That is, let's say 1 2 3. Oh, okay, it's easy. 1 2 3 4 5. Okay, first thing, 1 and 5. Answer is 4. It is not lesser than 0. It's okay. And final becomes answer, that is 4. Now 2 and 4. Answer is 2. Okay. Now we know that 2 is lesser than 4. That is, it is not greater than answer, and 2 is not lesser than 0. So we can continue going on. And since at 3 we have no other condition left, so we get out of the loop. And since we have never returned -1 or something like that, so we will print final. That is, the answer is we need 4 operations. Okay, this is the code, this is the explanation. I hope you get it. Thank you.